All right, next to last, number 9. If there is a 0.4 kilogram bead, 4 kilograms, and it is sliding straight on a frictionless wire, which allows us to not take into account any forces, any impulses that are going on in this particular example. And we can, let's see, say that it has a velocity of 3.5 centimeters per second. 3.5, this is initial, centimeters per second to the right. It collides with a larger bead, the mass. So this is going to be 1. This is the mass of the second one, 0.6 kilograms. I'm going to do this one in red. All of object 2 is going to be red. That's my goal. And its initial velocity is 0 because it's at rest. Okay? This is the initial state. These are mass times velocity give us the initial momentum. After the collision, the smaller bead moves to the left with a velocity of 0.7. Okay? So after the collision, I've got to go back to blue. Mass 1 is still 0.4, but this time its final velocity is 0.7 centimeters per second, and it's to the left. Okay, very important, to the left. So I called it negative because at the beginning it was moving to the right, that's positive. If it's moving to the left, we have to change the sign. Find the distance the larger bead moves along the wire in the first 5 seconds following the collision. Well, how can I figure that out? Well, there's no friction, first of all, so there's nothing to take away its velocity. So if we can find the velocity afterwards, then we have that thing's velocity for all time. So it still has a mass of 0.6, but we don't know the final velocity of mass number 2. Centimeters per second. Okay, here's the million-dollar question for this one. Maybe you didn't even think of it, but can I keep these in centimeters per second? The answer is yes, because every single term, when I do this equation, I'm going to do conservation of momentum, which says that the initial momentum of both objects, which now is going to be in kilograms times centimeters per second, is going to be equal to the final momentum and if all the velocities have the same units, then at the end the units will come out to be centimeters per second because I'm trying to find the final velocity. You could convert them and then you can convert it back and you can see that that's true. All right, so at the beginning, one of these things doesn't have any momentum. So no bother to continue writing that down. Anything times 0 is 0, and that means it goes away. So we'll have 1.4 kilograms times centimeters per second of momentum at the beginning. That means at the end we have to have the same amount. But the second ball is going to appear to have more momentum than that because it does, because this first ball has negative momentum now. Plus 0.6, B final. So I have to add 0.28 to the initial momentum because 1.4 was all in the positive direction, and now I've got some crazy momentum going the negative direction. So I'm going to have to divide that by 0.6, and I get a final, that's not right. I get a final velocity for that second object of 2.8, and that is centimeters per second. Okay, this is important, but it is not the final answer. Final answer has to do with how far it will go in 5 seconds. So if you remember, velocity is change in position over change in time. So that means change in position is just velocity times the amount of time. We know it's going 2.8 centimeters per second, and it's traveling for 5 seconds. See, the seconds are going to cancel each other out. And so the change in position is just 2.8 times 5, or 14 centimeters. The end.